All right, we're going to work through the first example together. It's a numerical example, as you guys can see right here. Numerical example just meaning we're given data. The data we're given will be the velocity values of some kind of object moving along the x-axis. Okay, the velocity v is differentiable. That's an important word because it implies continuity. So that means that even though these are the only data points we have, we do know that if we were to plot these points, which that would be very manageable, that if we plotted these points that we'd have to connect them with the smooth curve. So there'd be no points of discontinuity. So everywhere from 0 to 12, we would have to draw a graph connected. So pay attention to the fact that this is differentiable. It implies continuity. This is not discrete data. Something else that you might want to pay attention to are the units that are given along the quantities. So time is measured in minutes and velocity is measured in meters per minute. Based on worksheet number 1, that content, that vocabulary, that information, we're going to answer some of these questions. At time equals 0, is the particle moving to the right or the left? Explain your answer. This is a two-part problem, so to speak, meaning you're going to get points for the correct answer and points for explaining correctly. So let's go ahead and take the question and make it our answer. It's just good sentence structure. So I'm going to go ahead and rewrite their question. At time equals 0, the particle is moving. Let's locate time value of 0. Let's locate what kind of velocity it is. It's a negative velocity. If we have a negative velocity and our motion is horizontal, we know we're moving left. So the particle is moving left because v at 0 is negative. You can put is equal to -3, which is less than 0. Oops. Squeeze that over. Or you could just use words. You could put v of 0 is negative. Symbols are words. This would be worth 1 point here, and this would be worth your second point in your explanation. Question 2. Is there a time during the time interval from 0 to 12, including 0 and 12? So notice that covers the entire data table. Is there a time on that interval when the particle is at rest? Well, if you were to look back at the worksheet number 1, at rest means velocity is 0. Well, I don't specifically see a v value that's equal to 0. But remember that the velocity function is differentiable. Pay attention to the signs of the velocities. Okay, here at time equals 0, the velocity is negative. Okay, and then right here at time 2 seconds, the velocity is positive. Remember, if you're plotting these points, that if you plotted these as ordered pairs, there's no way you could go from a v value or a y value of -3 to a y value of 2. There's no way you can go from a -3 y value to a positive 2 y value without passing through 0. We saw that the other day as the intermediate value theorem. So we're going to come down here and we're going to say, well, yeah, there has to be a time when the particle's at rest, explaining my answer. So let's go ahead and take the question and make it our answer. Yes. The particle is at rest sometime between, well, let's pinpoint the time interval on which we have a sign change. So between t equals 0 and t equals 2. Well, that answers the question, but now we need to explain our answer because v of t changes from negative to positive. you'd get full credit if you remember that this is the intermediate value theorem and you threw that out there. If you said because of the IVT, that's all you'd have to say. Because we know that for the intermediate value theorem, the if part of that is that the function has to be continuous. And we know the velocity function here in this problem is continuous because we were told it was differentiable. They would be satisfied with the response of because of the IVT. If you don't remember the name of the theorem, that's okay. Because you can say velocity has to change from negative to positive. Do you have to point out that it's continuous? No, because in the given, the stem of the problem, they told you it was differentiable. So you don't have to point out that obvious. It'd be fine if you did. Number 3. Here's some other questions that you might be asked being given some data. Use data from the table to find an approximation for the rate of change of velocity, the slope of the velocity, v prime, at time equals 10. Explain the meaning of v prime of 10 in terms of the motion of the particle. Show your work and indicate units of measure. Okay, well, I'm going to be finding the slope at 10. Slope will be your y units divided by your x units. So all you have to do is go up and still the units of velocity, meters per minute, and put it over the units of time, minutes. So if anything, if you can't answer anything else, if you can answer the units, then you'll get a point for that. All right, so how do we find an approximation for v prime of 10, the slope of the graph at 10, when I don't even have a data point at 10? Notice that 10 fits in nicely between 8 and 12. If they asked me to find v prime of 9, I'd still be locating 9 in between 8 and 12. Okay. If they asked me to estimate the rate of change of velocity at 8, if they asked me to find v prime of 8, I'd still use the points 8 and 12. I could use the points 6 and 8 in that case, or if I'm finding v prime of 8, I could use 6 and 12. Okay. If you're estimating at a time value they give you, and it's in the data table, you have 3 choices like I mentioned. So if it was v prime of 8, you could use the points 8 and 12, 6 and 8, or 6 and 12. Okay. But in our problem right here, v prime of 10 fits nicely between 8 and 12, so we're going to go ahead and use these 2 points to estimate the rate of change, meaning we're going to find an average rate of change. So it's just a delta y over delta x. So v prime of 10, the slope at 10, whatever it is, would be the velocity at 12 minus the velocity at 8 over 12 minus 8. So I'm going to put the numbers in here and then include the units as well. So I'm going to have 5 minus 7 meters per minute, and then 4 minutes. So it looks like negative 1/2 meters per minute squared, or you can just leave it in this format right here. All right, so let me go back and check I'm going to check the work that I've done and check the question that I was asked to find. All right, use data from the table. Yep, I found an approximation. I have not explained the meaning of this slope in terms of the motion of the particle. I have shown the computations that lead to my answer and indicated units of measure. Okay, so now I'm going to come down here. V prime of 10 means 2 things. Oops. Let's bring in 2 things here. When you're asked to explain the meaning of something, you want to talk about the input and the output. The input is the time, 10 minutes, and the output is a rate of change. So in the context of the motion of the particle, I'm going to say v prime of 10 means at time equals 10 minutes, the acceleration, because the slope of velocity is acceleration, the acceleration of the particle is And I'm going to go ahead and report the answer again. -1/2 meters per minute every minute. So that's a good format to follow as far as explaining the meaning of something. Think about the input. Okay, so here it was 10, and the answer we got, the output. And then put some context to it, and you're good to go. All right, question 4. Let A of t denote the acceleration of the particle at time t. Got it. Now, remember, we weren't given a velocity equation. We were just given some data. So just kind of keep that in your mind. Let A of t denote the acceleration of the particle at time t. Is there guaranteed to be a time equals c between 0 and 12 such that the acceleration is 0? Justify your answer. Well, based on the data that I'm given for velocity, if my acceleration is going to be 0, then that would mean that my velocity has to change direction. My velocity would have to change direction. The slope would have to be 0 somewhere on the graph of this velocity function. Well, if I were to plot those points, which I strongly encourage you to do so, if I were to plot those points, do those points ever indicate to me that velocity changes direction from increasing to decreasing or vice versa? Okay, now remember, let's kind of back up here. That first condition that has to be met is that I have a differentiable function. Yes, I do have a differentiable function here. This is really Rolle's theorem. I'm looking for a slope of 0, Rolle's theorem. Okay, and Rolle's theorem has us make certain that our function is differentiable. We're told it's differentiable, so that's out of the way. Rolle's theorem also tells us that the y values have to be the same, and we're guaranteed a 0 slope. Well, because I'm only given a limited amount of data, it's more about, does the function ever change direction? Because if it does, then I know I have a 0 slope. All right, so let's study the data. I'm going from a negative velocity, increasing, increasing, increasing still. Now, you know that in between 0 and 2, there's a lot that could be happening, but right now, all I can do is say that at least one time, the velocity function is increasing, 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 increases to 5, increases to 7. Somewhere in this region right here, and this velocity function is going to have to decrease to get back down to a y value of 5. So I see that at least one time my velocity values change direction. So again, velocity is increasing from -3 to +2, increases to 3, to 5, to 7, but then drops back down. There has to be one time within this interval from 0 to 12 that the acceleration is 0 then. Velocity is increasing, that means acceleration is positive. Velocity starts to decrease, that means acceleration is negative. And a change of slopes from positive to negative indicates a maximum. And because it's differentiable, we have a 0 slope. So we're going to take that information that we've just kind of discovered and put it down here to an answer. Yes?
Attention in the building. Attention in the building. Janesha Brown. Janesha Brown, would you please come to the AP office? Janesha, come to the AP office. Thank you.
All right. Yes, there's going to be a time t equals c when a of c equals 0. That's part of the points because v of t changes from increasing to decreases. And if you wanted to, you could say, and Rolle's theorem applies. You don't have to. It would be enough. You would get total credit if you said that V of t changes from increasing to decreasing. Okay, we have been working with relationships from F, F prime, and F double prime, and we're going to continue to work with those relationships, but now with context. Context with position, velocity, and acceleration.